Lesson 7.4. We will solve systems of equations using combinations method, also known as eliminations. So it has two names, combinations or eliminations. We will try to refer to it as combinations, okay? But its street name is eliminations. So please have that down. All right, so first things first. You need to recall what a system is, okay? How many equations make up that system? Well, you're going to have two, because you're comparing two different things. You could be comparing roses and carnations. They're both flowers, but they're different. So that could be two different things. You could be comparing markers and pencils, okay? Those could be the two different things you're comparing. So you have to, it makes up at least two. How do we write the solution? I hope you know how to do this. As in ordered pair, okay? We have an x comma y. How have you learned to solve a system so far? So what's the last way that we learned how to solve a system of equations? We've learned it through graphical representation. We have the graph, we have the two lines that intersect, and we find that point of intersection. We also know substitution, which is what we learned in the last video. We know that if y is equal to 3x, that means y is equal to 3x. We can plug it in for y, and we can solve for x. Okay? Today, we're going to learn a third way, which is combinations. Okay? So what does it mean to combine? Well, if I have apples and oranges, then I have to combine all of my oranges, and I have to combine all of my apples. Okay? It's combining the two things. Just like when we learned about the distributive property and combining like terms. That's exactly what we're going to do to isolate the variable. Okay? So here we go. Here's our system of equations. Now, you will note that I've already stacked them for you. If they don't come stacked, you need to stack them. Here are some notes on the side. You might want to take a minute now to pause and write that down. So that as I go through this, you have a point of reference. Okay, so go ahead and pause now and write down these notes. All right, you're back. So the first things first, when we have our two systems, okay, we don't have anybody that equals y, okay, so we're not going to do any substitution. We have to do a combination. We have x's and we have y's. The first thing you need to look for is if you have any zero pairs. Because the whole purpose is to isolate the variable. We need x to equal something so that I can plug it back in. Right now I have an x and a y and I can't solve for that. So I want you to look at this system. Can I make a zero pair anywhere? Well, look at my x's. I have positive x and positive x. Well, if I put those together, that's going to give me 2x. That doesn't go to 0. Well, look at my y's. I have a positive y and a negative y. They are opposites of each other. They are also zero pairs. So these are going to end up canceling, which is good. All right, here's the whole deal with combinations. You set it up like an addition problem. Okay? So we're going to add these two. We need something to go away. All right? Let's see what is behind door number 1. Here we go. Let me get my pen so I can show you what just happened. All right? Stack them and combine. Or add. Okay? Add. Combine them. All right, so we have a positive y and a negative y. You guys already know that those are going to cancel. Well, if I have an x over here and an x over here, how many x's do I have? I have 2 x's. And you guys know if we do it to one side, we also have to do it to the other. So 10 plus 8 is 18. Well, now that looks like something we can solve. Okay? We know how to do that. I have 2x is equal to 18. I know that I have to divide by 2. And x is going to equal 9. Did we isolate the variable? Yes. We are now down to step 4. Plug that value back into one of the equations. Okay? Honestly, I don't care which one you plug it into. It should come up to be the same answer. Now let's see which one I picked. Oh, I picked the plus y. So I picked the first one. 9 plus y is equal to 10. I still don't know what y is. How can I solve for y? What do I have to do? Good. This is a positive 9. I need to get rid of it. I need to subtract 9 from both sides. And there we go. Where's my pen? I'm going to show you that they cancel. Y drops down. Y is equal to 1. What is the solution for this system of equations? 9, 1. That's where these two lines are going to intersect at this one point at 9, 1. That's where they'll intersect. Okay? Now, just for fun, so that you can see that it actually works, plug the 9 into the lower equation and see what you get. Okay? You should end up with 9 still. All right, here we go. Your turn. All right, so I'm going to make that nice and big so you can see it. I want you to do the same thing. Follow your steps. So pause it now, follow your steps, and see what you get as your solution. Get the correct tool here. All right, I'm going to walk through it because you have paused the video and you already did it. I'm going to set this up like an addition problem. Stack them. Looking for some zero pairs. Well, my y's are going to cancel again. Okay, so here we go. I end up with 2x is equal to 4. 6 minus 2 is 4. Or 6 plus a negative 2, that's still 4. I divide by 2, x is equal to 2. Now what do I have to do? I have to plug this 2 into one of these equations. I hope you already did that. Pick one, it doesn't matter. I'm going to plug it into the bottom one. 2 plus y equals negative 2. I need to get rid of the 2 so I can isolate the variable. Y is equal to negative 4. And in good systems, you always write as a solution, or as an ordered pair, I'm sorry. And there's my ordered pair. These two lines will intersect at this point. Now there's no context. This is what we call naked math, okay? It's just plain old math. There's no context. We're not talking about flowers or pens or markers or anything like that. This is just two lines and where they're going to intersect. Now, we can make up a whole story about that, but we're not going to do that right now. Okay? There's the solution. All right. Now, I knew you were going to ask this next question, so here it is. But what if I don't have immediate zero pairs? Look at that one. Write that down. Write down those systems. Do you have any zero pairs? Anything that's going to cancel right away? Nope. I got 3x and 1x. That's going to give me 4x. That's not going to go away. What about my y's? I have negative y and a positive 2y. Nope. That's going to end up with still 1y. That's not going to be beneficial. You have to find the least common multiple. Okay? So here's an extra step. What's the smallest thing that these two coefficients both go into? Okay? All right? Well, okay. So here's the I take that back. You want to look at, okay, which variable do you want to get rid of? Okay? Do you want to get rid of y or do you want to get rid of x? Okay? Now, to stay consistent with our theme, because here we got rid of y, here we got rid of y. Let's go back and let's get rid of y again. So if this is positive 2y, what would I have to multiply this whole first equation by to get a negative 2y so that these can cancel? And that's where our 2 comes in. Okay? I can multiply this entire first equation by 2, okay? Which is what I have done here, I hope. Yeah, there it is. Okay? Now you do it just to the first equation, but if you do it to the first equation, it's everything in that equation, okay? And I'm going to show you that in just a moment. Did anything happen to this second equation? Let me get my highlighter here. Anything happen to this equation? No, it's still the same, okay? But I do need to multiply this too, okay? Which is going to be what property? It's going to be the distributive property, very good, okay? Which is right here, all right? Oops, what happened? Let me delete that. There we go. Okay, look at what you end up with. Pause it, freeze frame it, and look at what happened. I had to multiply the entire first equation by 2. So now I have some zero pairs that I can cancel. Did anything happen to that second equation? No, it stayed the same. Now I have some zero pairs. I know that those are going to end up canceling. I can solve for x here. Okay? But some of you are very stingy. You forget to do everything in the parentheses. It's everything, absolutely everything. Let's make this big again so you can see it. All right, pause here. You solve for x. You know what to do now. Oops. Okay. 7x is equal to 21. X is equal to 3. Okay, we know the value of x. Now what do we have to do? You have to plug x in to one of these equations. Now, here's the thing. Hear me out. X is equal to 3. Can I plug it into here, here, or what about here? You can plug it into any of them. They are all the same. Okay, this was just this rearranged. This is after the distributive property. So you can plug it into either one of these if you choose. Or if you just want to be on the safe side and use the one that we didn't touch at all. Okay, the one highlighted. Let's see what I chose. I chose the one that we didn't touch at all. Okay, so there's no misconceptions. Plug in 3 for x, solve for y. Okay, let me highlight that so you can see it really well. X was 3, y ends up being 1. How do we always write our solutions? 3, 1 as an ordered pair. Let's see what was behind here. Nothing. Okay? Here's your solution. Right here. 3, 1. It's a lot. Okay? Especially if you're not able to make 0 pairs right away. All right? Now it's your turn. Pause it. Okay? For this example, I would like you to try to eliminate x first because that's how I'm going to show you the answer, okay? Technically, you can eliminate x or y. It doesn't matter. But here I want you to try to get rid of the x's. Now, here's what I want you to think about. I have 2x and I have 3x. If I want to get these to go away, what's the least common multiple? What's the smallest thing that both of these numbers go into? The least common multiple is 6, okay? That's the smallest number that both of those go into. So somehow I have to get one of these to positive 6 and one of them to negative 6. Do you have to multiply one or both? And the answer is you have to multiply both, okay? Now, let me see what okay. Just so we all stay on the same page, okay? We need to multiply this whole thing by 3. Oops, let me get a pen. There it is. This whole thing gets multiplied by 3. And now that's positive. That's still going to be positive. We need one of these to be negative so that they cancel. Okay? And we're going to do this one negative. This times negative 2. Everything in here. Okay? Take a minute. You have your notes. Do the distributive property. Solve for x. Solve for y. Okay? Here is the distributive property. Take a look at it, see what happened here. Let me put a box around it. It's this one right here. Okay? So here I multiplied by 3. Here I multiplied by negative 2. I cleaned all that up. I actually did the distributive property, and I ended up with 6x plus 9y equals negative 3. And then down here we have negative 6x minus 10y is equal to 4. Do I have 0 pairs now? Yes, we do. And they are right here. My x's are going to be able to cancel. Okay? Next slide. Oh, I'll leave it there. You pause and solve for x and y, because the next slide gives you the answer. Oops. Here we go. You solve for y. It should look like that. Negative y equals 1. You have to divide by negative 1. This is a negative y. And remember, there's an imaginary 1 out there. You have to divide by negative 1 on both sides. That's how they get y is equal to negative 1. Solve for x. Well, I know y, so now I can just pick either one of these equations and plug in. You've done that. Here it is. X should equal 1. Okay? Now look, they chose to use the original equation. You can use the original equation. You can use this. It all comes out. That's why math is cool, because you can interchange these things. Okay? So finally, you know how we write our answers. We write them as a solution. These two lines, this system of equations, will intersect at 1, negative 1. You've now been given 3 ways to solve a system of equations, okay? This way was combinations, setting it up like combinations. An addition problem, you're going to add those things together. There's substitution and there's graphing. I want you at the bottom of your notes today to write which way you like best so far. Do you like the graphing, the substitution, or the combinations? That's how I'm going to know that you watched the entire video.